In today's video, I will show how to implement form validation. Validating forms is crucial for ensuring data integrity and user experience. These are the features I will cover. HTML validation. I will show you how to utilize HTML attributes that can be used for validation. As you can see, we get an error message if an input is not valid. This is the simplest way to validate a form. CSS pseudo-classes. I will use validation-specific pseudo-classes to dynamically style the inputs. The input will be styled with icons and borders based on its validity state. Pop over to error text. Here, the error message displayed in the popover has been replaced by a text element. Custom validation. The password confirmation validation is custom built using JavaScript. Without further ado, let's dive right into the tutorial. To start, I'll add a form element with a heading inside it. Then, I'll create a div with the class of form control. Inside the form control, I'll add a label and an input for the username. Afterwards, I'll repeat this step for the email, password, and password confirmation. Lastly, I'll add a submit button. That's all the HTML part for now. Next, I'll go to the CSS file and start with the layout. For the form element, I'll give it a box-like appearance. I'll also set the minimum width and display the form as grid. Next, I'll set the label display to inline block so I can add a padding to it. I'll set the input to full width to position it below the label. Then add the following padding, border radius, and font size, which will also be used in the button for consistency. For the button, I will apply the following styles. That's all the CSS for now. Next, I'll start the HTML validation. First, I'm going to select all the input fields and set the required attributes, so that when I submit an empty form, I will not be able to proceed. Next, I'll set the proper type for each input. The username is text, but the email type should be email. As for the password inputs, the type should be password to mask the value. Now, I will get an error if I provide an invalid email. For the username, I will specify a minimum of 3 characters, so the username will not be too short. As for the password, I will set a regular expression pattern that enforces this criteria. It must contain at least 1 lowercase letter, 1 uppercase letter, 1 number, and 1 special symbol. It should only contain specific characters in this range and must be at least 8 characters long. You can find various password patterns through a quick search on Google. When I set an invalid password, the error message lacks clarity regarding the required format. Fortunately, we can use the title attribute to guide users with the expected format. That wraps up the HTML validation feature. Next, I want the input to display a green border if it's valid and red if not. The good thing is, we have pseudo-classes for that. I'll use the invalid pseudo-class on the input to apply a red border. Then use the valid pseudo-class to apply a green border. As you can see, the border color changes whenever the input's validity changes. Next, I will add a checkmark or X icon next to each input. To do that, I will use bootstrap icons. Then back to the CSS file. I'll set the position of the form control to relative. Next, I'll add right padding on the input to create space for the icon. Then, I'll add an after pseudo element to the form control. This pseudo element will contain the icon. Then, I'll set the position to absolute and move it to the right side of the form control. If the form control has a valid input, I will display the check icon in green color. Likewise, if the form control has an invalid input, I will display the X icon in red color. Now, there's one thing to note here when I reload the page. The form is immediately validated without any user interaction. That is just the default behavior. There's an alternative pseudo-class that is applied only when there is user interaction on the input. I will simply prefix the invalid pseudo-class with user. Now, the validation styles won't appear until I interact with the form. One thing to note here is how the code editor renders both pseudo-classes. It indicates that the user invalid pseudo-class has limited browser support, so it might not behave consistently across major browsers and may lead to unexpected results. At least, at the time when this video was published. Later, I will show a different approach for handling the validation styles. For now, let's move on to the next topic. Here, when I submit an invalid form, the error message appears as a popover. I will disable this and display the error message under the input field. First, I need to add an element for the error message. Back to the CSS file, I will set the error text display to block and make sure the min height value is set. It's important to set the visibility to hidden. When an input is not valid, the error text right next to it must be visible. As you can see, the error text element only shows when I provided an invalid input. Next, in the JavaScript file, I will select the form element and all the inputs inside it. If there are other input elements, they can be included like this. Next, I will disable the browser from validating the form. As you can see, when I submitted the form, it was not validated. Before we continue, let's take a look on the constraint validation API. To interactively validate the form, use report validity method. This will return a Boolean value and also report the error to the user. To statically validate the form, use the check validity method. These two methods can also be invoked on individual inputs. Here, I will call both methods on the username input. As an alternative, we can also utilize the validity state available for each input. This validity property will provide us with more detailed information about the error. In this case, the input is not valid because the value is missing. If I provide the username with only one character, it is still not valid, but the value is no longer missing. Instead, the validity state shows the provided value is too short. And when I set the required minimum character, the input is finally valid. If I enter a value in the email field, the validity state indicates a type mismatch because the input requires a valid email address. And if I set a value in the password field, the validity states is now true on the pattern mismatch, indicating that the password format was not met, such as having one uppercase letter, one lowercase, and so on. More information about validity states can be found on the MDN web docs. To get an input's error message, simply access the validation message property. If the input is valid, the validation message will be empty. To set a custom error message, use the method setCustomValidity. If you give the method with an empty value, it simply falls back to the original error message. There's one thing to note about this method. If the input is valid and the custom validity is set, the input automatically becomes invalid. If the custom validity is reset, the input returns to its valid state. Now that we have a better understanding of the constraints validation API, let's implement it in the code. First, I'll add a submit event handler for the form. Next, I'll add a condition to check if the form is valid. If it's not valid, I'll prevent the form submission. Now that we have a check for the form's validity, let's identify which inputs are not valid. First, I'll retrieve the element where the error message will be displayed. If it does not exist, create it as a fallback. Next, I'll set the text content of the error text element to the input's validation message. Here, when I submit the invalid form, the error text element was updated, although it remains hidden. This is because I only updated the text without triggering the validation styles. To fix that, I'll call setCustomValidity with an empty value. Remember, if the custom message is empty, it will fall back to the original error message. But this action will apply the validation styles. Next, let's tackle the alternative approach for user invalid. Instead of using the pseudo-class, I'll utilize a class. Back to the JavaScript file, I'll toggle the invalid class with checkValidity method. Now that we've removed the pseudo-class, the invalid styles are not applied upon user interaction. To fix this, I'll add an event listener to each input and run the validation check manually. The event can either be change or input, depending on the situation. Now, regardless of whether I interacted with the form or not, the inputs will be validated accordingly. And that's how we can effectively validate forms without duplicating the validation logic in HTML. At this point, I have successfully turned the error popover into a text element. The last topic I'm going to cover is custom validation. As much as possible, I'd like to use the built-in HTML validation for its simplicity and compatibility across different browsers. However, sometimes we need to validate inputs beyond standard HTML attributes, such as ensuring password confirmation matches the entered password. So let's tackle that now. First, I'll define an object containing validation rules, where the keys in the object will correspond to the input ID, and the value will also be an object. Inside the object, I'll use the name of the rule as the key. There can be multiple validation rules for a given input, so I will format it this way. By the way, I'm also adding rules for the username to show how this approach can be flexible if there are multiple inputs with custom validation. Even though the HTML validation already covers required and min length, I'll include it just to show the structure of the rules object. For the password confirmation, I'll define a match key. Then I'll be adding a target key to specify the ID of the element to be matched. Next, I'll define a function that will check the custom validation. Then, I will call this function here, just before the input validity is checked. Back to the check validation rules function. I will add a condition to skip the inputs without custom validation. Next, I will loop through each validation rule. Then I will apply each validation rule to the specified input. Here, I'll retrieve the object associated with the specified rule. Next, I'll make a switch statement to handle the different validation rules. For the match case, I'll get the input to compare with. And just in case the match input is not found, I'll throw an error to stop the validation. Next, I'll check if the current input and the match input values are the same. If not, I will set the custom validity to make the current input invalid. Now, I will test if the custom validation works. Seems like it does. However, there's one thing to consider here. Here, the password confirmation only becomes invalid after I leave the field. To fix that, simply change this event into input. However, this depends on the situation. If the validation is very extensive, it might be better to stick with the change event. As mentioned earlier, the rules for the username is to demonstrate the flexibility of this custom validation. I won't go into further detail on the implementation of each case. Just keep in mind that you can add a case for each custom validation rule. Now that I've demonstrated how to implement custom validation, I'll remove the min-length example since there's already a built-in HTML validation for it. Here, we get the default error message for invalid password format. If you remember, I set the title attribute for the password to convey the password format to the user. So, I'll change this default error message. Here, I'll add a condition if the pattern mismatch is true. Then, I'll set the input title as the error message. If the title attribute is not specified, it will simply fall back to the original error message. That wraps up the custom validation feature. I hope it wasn't too overwhelming for you. If you have any questions, feel free to drop a comment. I'll do my best to answer them. I've taken this approach to ensure that the implementation is flexible, so that there's minimal modification when you want it to work on multiple forms. Before we end this video, let's revisit the CSS file and implement one more thing. I'll ensure that the invalid style is applied even when JavaScript is disabled. We can achieve this by checking for the presence of the noValidate attribute on the form element. That's why I didn't set it directly in the HTML file, but instead used JavaScript to handle it. As you can see, JavaScript added the noValidate attribute to the form. If JavaScript is disabled and the page is reloaded, the noValidate attribute is removed. Furthermore, the invalid pseudo-class styles are automatically applied. The error message also reverts to the popover. As for the password confirmation, the backend should handle the validation. That's it for the last update. If I missed anything, let me know in the comments. If you found this tutorial helpful, please consider subscribing, liking, and sharing it. Your support is greatly appreciated.